In the infinite, unfathomable expanse of the cosmos, a celestial traveler of cosmic origins has traversed billions of years, journeying through regions of the galaxy that were formed eons before our sun even came into existence. This celestial wanderer, christened as 3I Atlas, is the third known interstellar comet to visit our solar neighborhood, leaving astronomers spellbound with its unique characteristics and unusual orbit. This video aims to provide a comprehensive exploration of the recent discoveries and updates regarding this captivating comet, focusing primarily on the most recent scientific observations made by numerous teams using various telescopes in the past 6 weeks. As you may recall, this object was discovered on July 1, 2025, by the NASA-funded Asteroid Threat Assessment and Defense System, ATLAS, referred to as ATLAS for short. Within approximately 24 hours, it was confirmed as an interstellar object due to its rapid velocity, which was significantly higher than that of the previous interstellar comets, Oumuamua and Comet Berry. 3I Atlas was moving at an unbound hyperbolic path with an excess velocity of 58 kilometers per second, far surpassing the velocities of Oumuamua, 26 km/h, and Comet Berry, 32 km/h. Moreover, its trajectory was extremely hyperbolic, with an eccentricity of 6.13, making its path appear almost straight instead of curved. As the comet approaches the sun, its velocity will increase even more, reaching a maximum speed of 68 km/h at perihelion. Unfortunately, at this time, we won't be able to observe it because it will be behind the sun. Once it starts leaving the solar system, its velocity will gradually slow down, but it will still remain one of the fastest objects in the solar system. One of the more intriguing discoveries about 3I Atlas concerns its trajectory, specifically its origin and its vertical velocity. At present, what we have gleaned is that it appears to have originated from the southern celestial hemisphere, opposite the direction of the sun's movement relative to local stars. More significantly, it was moving upward through the galactic plane with a vertical velocity of 18.5 km/h relative to the sun, which is quite unusual compared to nearby stars and other interstellar objects. Essentially, this implies that 3I Atlas follows a tilted orbit around the Milky Way, possibly resembling something like the elliptical orbit depicted in Figure 1. Furthermore, researchers have estimated that 3I Atlas is at least 7.6 to 14 billion years old, with approximately 70% confidence, making it the oldest comet ever seen and much, much older than the solar system, which formed 4.6 billion years ago. It is fascinating that for this entire duration, this comet was very likely just drifting through space, not interacting with anything, with the sun being the first star it's seen in a very long time. The most exciting feature of 3I Atlas is its cometary activity, which will be analyzed extensively to discern what this object is made of. Scientists have already made some surprising discoveries concerning its chemical composition. For instance, observations by NASA's tests revealed that 3I Atlas was already exhibiting cometary activity as early as May 7, 2025, approximately 2 months before its official discovery. At this time, it was much farther away than Jupiter, and this early activity is particularly noteworthy because temperatures at such distances are usually too cold for water ice to sublimate. This suggests that the initial activity was likely driven by the sublimation of much more volatile ice, something other than water. Additionally, water ice was detected between July 5 and 14, 2025, and several separate telescopes were able to confirm the existence of water, observing both water vapor and hydroxide ions. This water vapor and hydroxides were visible approximately 3.5 astronomical units away from the sun, which is technically a little bit unusual for a comet, because normally we don't expect detectable amounts of water vapor and even hydroxides, such large distances due to very cold temperatures. Scientists believe that this water vapor and hydroxides detected by these telescopes seem to be produced by sublimation of water ice grains, which must have been ejected from the nucleus by outgassing of something much more volatile, such as carbon dioxide or carbon monoxide. The active surface area for this entire comet seems to be very large, with approximately 20% of the surface area evaporating, which is much higher, or approximately 4 times higher, than we will usually see in a typical comet in the solar system. This increased activity is explained by the hypothesis that this comet has never seen another star for at least several billion years, suggesting that it has a tremendous reserve of very pristine materials that are finally evaporating because the Sun is the first star they've ever seen. In terms of other volatile elements, initial spectroscopic observations from early July of 2025 seem to have discovered no evidence of gas emissions containing cyanides, dicarbons, tricarbons, or oxygen. This is a bit surprising for astronomers, as the absence of cyanide generators, also known as CNs, which usually have a very low sublimation point, and a typical D first signals detected in comets seems to be just a little bit unusual. There are at least 2 potential explanations for this phenomenon. First, there may be a thick layer of irradiated organic compounds that appears to suppress volatile outgassing from the surface of this comet. The other explanation is the low metallicity origins of this comet, or essentially, the fact that it came from some really ancient stars containing very low amounts of heavier elements, suggesting that this unusual comet is just carbon pure and extremely enriched in water compared to anything in a solar system. Moreover, the comet appears to be reddish in invisible wavelengths, similar to D-type asteroids in our solar system and even previously discovered Comet Berry, which contained reddish complex organic compounds that must have been created through the exposure to cosmic radiation. This is the same color and the same reason Pluto is red. In conclusion, 3I Atlas is a truly unique opportunity to study processes of planetary formation in distant star systems and in a very different galactic environment from where the Sun was formed billions of years ago. Its unusual age, origin, and distinct cometary activity make it the most studied object in 2025, and there is an ongoing race to learn as much about it as possible. The Vera Rubin Observatory is expected to discover even more of these objects in the future due to its higher sensitivity and superior ability to see these objects at all times. As we continue to observe and analyze 3I Atlas, we will undoubtedly uncover more about this fascinating celestial traveler and the distant star systems it represents. Figure 1. Illustration of 3I Atlas's tilted orbit around the Milky Way. The comet approaches the Sun, S, from the southern celestial hemisphere and passes through the galactic plane at a vertical velocity of 18.5 km/s relative to the Sun. The comet's orbit is extremely hyperbolic, with an eccentricity of 6.13, making its path appear almost straight instead of curved. The comet is shown at perihelion, B, and the aphelion, A, points of its orbit. As we delve deeper into the study of 3I Atlas, we are not only learning more about this unique interstellar comet, but also gaining insights into the origins of our solar system and the formation of celestial bodies. The discoveries made about 3I Atlas will help us understand the processes that shaped our solar system and the role of interstellar travel in the evolution of galaxies. The ongoing observations and analysis of 3I Atlas are a testament to the boundless curiosity and perseverance of humanity in exploring the unknown and unveiling the mysteries of the universe. This exploration of 3I Atlas also brings forth a sense of awe and wonder, reminding us of our place in the cosmos. As we continue to uncover more about this celestial traveler, we are not only learning about its unique properties, but also about the vastness of the universe and the potential for life beyond our planet. The study of 3I Atlas serves as a beacon of hope, inspiring us to continue our quest for knowledge and understanding, and to never stop exploring the great unknown. In the grand scheme of things, the discovery of 3I Atlas is but a small step in our ongoing journey to understand the universe. However, it is a significant step, serving as a testament to the power of human curiosity and the relentless pursuit of knowledge. As we continue to study this celestial traveler, we are not only adding to our understanding of the universe, but also inspiring future generations to continue the quest for knowledge and understanding, and to never stop exploring the great unknown. In the end, the discovery of 3I Atlas is a reminder that we are not alone in the universe. There are countless celestial travelers, each with their own unique stories and origins, waiting to be discovered. The universe is vast, mysterious, and filled with wonders just waiting to be unveiled. And as long as we continue to explore, to learn, and to question, we will undoubtedly continue to uncover more about the universe and our place within it. So let us continue to explore, to learn, and to question, and let us never stop striving to understand the great unknown.